In this lesson, we're going to look at our last vector operation. We're going to call this the cross product. The cross product, unlike the dot product, produces a vector. So when we're done this process, we'll have a vector. This vector is perpendicular to two other vectors. Now we've done this before, and we in fact did this a long way. Sometimes I asked you in our last unit for the normal, the vector perpendicular to two other things. And we had to do a dot n comes out to 0, and b dot n comes out to 0, and use some algebra to solve for that. Well, today we're going to learn the shortcut. Okay. As long as a and b are two tail-to-tail vectors in our plane, the cross product will produce a perpendicular one. So here's my diagram, if you will. I got a and b pointing different ways. When I cross them, and this is my symbol for crossing, I'll get a vector that goes this way. It's perpendicular to b, and it's also perpendicular to a. Okay, notice that the order is important. Okay, b cross a is different than a cross b. They're in fact opposite vectors. One points one direction, the other one points the opposite direction, as you can see in the picture. So they'll have the same numbers, they'll just be opposite signs. So just be careful. Okay. How are we going to do this process? Well, since there's actually an infinite number of perpendicular vectors, think about the floor and all the legs of the desks. Those are all normal to the floor. There's an infinite number of those. We're going to pick one. Okay. If you want other ones, do some scalar multiples, but we're going to do one. To get this one, we could use this crazy looking formula. This is actually the formula for how to do it. It totally works. And if you really want to memorize that formula, go for it. But I have a little shortcut for you. We call it the crisscross method. To use this method, what we're going to do is take the components of vector A. That's the first thing in my cross product, whatever is first. And we're going to put them in the order from the second thing to the third thing to the first, and then back to the second. That's what this is showing. Okay, I'm going to do an example as we do it so you can see how this works. So I'm going to start with the second thing, and then the third thing, third component, your z, back to your x component, and then your y component. You can do the exact same thing with your b's, with the second vector. So your y component, your z component, x, back to y. And then we're going to crisscross. What the crisscross does is it multiplies a2 times b3, which if you notice is the first part of the formula. So in our case, we're going to get, let's write this out here, 3 times 4 makes 12. And then you're going to subtract, as the formula says, always, and you crisscross back up, which again, if you notice, is the second part of the formula. So by writing out the numbers the way I did, it's actually taking care of the formula for us. 4 times negative 2 makes negative 8. So you can put it in brackets, negative and negative. And we're going to do it again. Now it's going to do 4 times 1 minus, it's always minus, negative 2 times 4, it's negative 8, comma. We're doing commas because, remember, we're making a vector, so these are our components. Negative 2 times negative 2 is 4, and 3 times 1 makes 3. Again, it's minus. Now, if you want to, whenever you have a minus, you can think of it as a plus. That helps in your brain, or just write it out the way I did and do your math afterwards. And we should end up with 20, 12, and 1. And there is a vector that's perpendicular to both A and B. In 3 space, if this was your A and this was your B, you've just created something that's perpendicular to that and that at the same time. Obviously, it's hard to draw in 3 space, so you kind of need to imagine this idea. If you put your hands together and point your 2 pointer fingers out and then raise your thumbs, that's what you've created. Okay, it takes a little bit of practice, mental math skills. Okay, what's kind of nice about it is you can also check it to make sure you're right. The whole idea of creating a perpendicular vector is that when I dot it with my original vector, it should come out to 0. So when you've got your A cross B done and you want to say, hey, did I get it right? You can choose to either dot it with A or dot it with B. Your choice, doesn't really make a difference which. You could also do both if you really want to. But either way, it should come out to 0. So if we test it out, let's go back for a second here. A was -2, 3, and 4. If I take that and I dot it with what I thought A cross B was, which we had 20, 12, and 1, and I do my multiplication here, -2 times 20 is -40. 3 and 12 makes 36. We're making a scalar here, right? So we're adding. And what does that come out to? Oh, it comes out to 0. Hey, I got my cross product right. I know it's right. I just tested it out. I could have also, if I wanted to, use B. So 1, -2, and 4 with the same cross product. So 20, 12, and 1. 20, 12, 1. If we dot those ones, you get 20, -24, and 4. And what does that come out to? Also 0. So I've just proven that I have the right cross product. Because when I dotted it, it came out to 0, which means it's perpendicular. Okay, I'm going to get you guys to try. So pause this as necessary. You might need me to go through the first one again with you, but then try the second one yourself. Okay, we're going to try and do V cross U. So Y component, Z, X, back to Y. -1, 4, 0, -1. We're going to crisscross. So -12 minus, it's minus -5, so I'm going to write this as a +5. It's really like doing a minus minus. 5 times 0, that's nice. 0 minus 8, and -2 minus 0. Okay, I think you should have -7, -8, and -2. I'm going to test it out by dotting it. So I'm going to go back to the beginning here and I'll do a V. So 2 times -7. 2 times -7 is -14. And -3 times -8 is +24. Those are Y's. And Z's, we need to do a 5 and a -2. That's -10. Looks like 0 to me. I got it right. Okay. You guys try the last one. Just move it down here so I have some space. Okay, pause, try yourself. M cross N, not dot. Okay, -1, 3, 2, -1, -1, 2, 3, -1. Oh, I use the same numbers, different signs in there, so be careful. Okay, what do we got? We got -2 minus, -1, -3. That's a plus. 9 minus 4. And -2 minus, -3. So I'm going to make it a plus. Okay, I think it's 1, 5, and 1. I'm going to dot it with this one this time. Okay, so X is together. X is together is 3. Y is together is -5. Z's together is 2. I'm pretty sure that comes out to 0 if I add it all up. I got it right. Just proved it. Okay, let's do some problems. Okay, find the cross product of these two vectors for me if you would. Let's see what happens. Explain our answers. So no tricks here. I just want you to do M cross N. -1, 2, 3, and -1. 2, -4, -6, and 2. Okay. Cross product, 4 minus 4. -6, -12, minus, minus a negative, so plus, it's also 12. 6 minus 6. Oh, what do we notice here? We get 0, 0, 0. Why did that happen? What weird thing have we done here? Well, if you had actually paused and looked at the beginning of the question, maybe some of you did, you might have noticed something about these two vectors. These two vectors are scalar multiples. These are two parallel vectors. So you can't be perpendicular to both at the same time because they're actually the same vector. There's only one vector to be perpendicular to. So you can't find a cross product of scalar multiples. What's going to happen every single time is you'll get the 0 vector. So if you ever come across that, it's not the end of the world. You just didn't notice that you had scalar multiples, which is actually one of the big properties of cross products. Here are some other ones. Some of which we talked about already. Okay? First of all, order matters. P and Q is the opposite of Q and P. They point different directions. One would be up, one would be down, or left, right. Okay? You can actually distribute with a cross product. So you could add together, then take a cross product, or cross product, then add together. That works too. If you have a scalar, just some sort of number, you can do your cross product first, and then take the scalar multiple of it, or scalar multiple each of your vectors first, and then cross product them. That would work too. And as we just said, collinear vectors, or scalar multiples, will always create the 0 vector. We just did this, right? We had a scalar multiple. Okay, just some ideas that things we can do with it. And we're going to try and prove one of these things. So one of our things we just said is you could distribute. So can we prove, this is really just practicing our operations, so can you verify these two things are true? So let's work left side and right side. So on the left side, what would I do first? Well, first of all, I have you guys pause it and try it. But if I was working on this, BEDMAS says I do the brackets first. So can I add Q and R? Yeah, sure I can. If I add my components, I get 0 and 3 and 7. Make sure you're using Q and R. That's going to be the trick to this question. Now, can I cross P with that new answer? Sure I can. Be careful with the order. P, -2, 4, 1, -2. And my new vector, 3, 7, 0, 3. Okay, let's cross product this mess. So I'll get -14 minus 12. We'll get 0 minus 7. And we'll get 3 minus nothing. So I think we should have -26, -7, and 3. That's just working with vector operations. Okay, let's do the same thing on the right side, except for this time we're going to start with the cross products and then add them together. So, or am I going to do this? I'm going to run out of room here, I think, real quick. Okay, let's try to do P times Q, or P cross Q right here. We'll do it small. Okay, P, -2, 4, 1, -2. And we're doing Q, so 2, 7, 1, 2. Okay, I think we should have -14 minus 8. That's this one. I think we should have 4 minus 7. And I think we should have 2 minus -2. So how about 2 plus 2? That gives me -22, -3, and 4. Oh, but I also need P cross R, so let's do that one down here. P cross R is, okay, P was these numbers. R, pick the right one here, 1, 0, -1, 1. We'll get 0 minus 4. We'll get -4 minus 0. And we'll get 1, and I got a minus with these two here, so plus 2. Gives me -4, -4, and 3. And if I did this right, it says I'm supposed to add these two things together. Well, if I do that, -22 and -14, -4 makes -26. 3 and 4 makes -7. 4 and 3 makes +7. And uh-oh, I got a mistake in here. How do I know I have a mistake? Well, I should have come out to 3. So, let's go back and look at my mistakes. Where did I do it? What do we got? P and Q. Did I write them down in the right order? -2, -4, 1, 2. Yep. And Q, 2, 7, 1, 2 looks good. Okay, I'm looking at just really the Z components. So I had a 2 minus a -2. That should be 4. I think that part's right. Then let's look at P and R down here. -2, 4, 1, -2 looks good. R 1 0 negative 1 1. That looks good. Oh, I see my mistake. I have to do 1 minus 2. I didn't do that. I did 1 plus 2. Let's fix that. 1 plus 2. See, easy to make a little mistake. Easy to go back and check though. 1 minus 2. I'm going to fix that guy. That should be negative 1 now. If I add them together now, hopefully I get the right answer down here now. Let's see, 4 and negative 1 makes 3, and hey, I verified it. It's the same answer. That was my goal. Okay. So we have this technique, cross product, dot product, adding, subtracting. What can we use some of these things for? Well, missed one thing. The cross product is actually used to find a geometric area. It finds the area of both parallelograms and triangles in 3 space. To find the area of a parallelogram, okay, we take our cross product and then find its magnitude. To find the area of a triangle, same thing, except for you have to divide it by 2, because a triangle is half a parallelogram. Let's try one of these out. So, determine the area of the parallelogram, basic one, defined by A and B. Well, I can do that by crossing A and B. So same old things. There's no tricks to how we do this. It's just what do we use it for now. So we're going to get hopefully 4 minus 6. Hopefully no mistakes this time. 0 minus negative 4. Oh, it's plus 4. And negative 3 minus 0. So I'm thinking the vector is that guy. Okay. But to find the area, I take the magnitude of this. So I take my A cross B, and we're going to take the square root of our components. So 2 squared, 4 squared, and negative 3 squared, which I believe is root 29. That's not a very nice decimal, so that's okay, just leave it. Just give me the word units squared afterwards. There's my area, parallelogram, done. Okay, you guys can try the last one here. Can you find me the area of the triangle? Formed by this information. Okay, pause it, try it. I'm hoping that when you did that, your first thing you said to yourself was, well, I need vectors. I got points. So I'm going to create some vectors. So I'm going to do my vector subtraction. So I'm going to say that A is AB, if that makes sense to you guys. So B minus A is negative 1, 0, negative 1. I need a second vector, and you have a choice here. You can do AB, AC, BC. It doesn't really make a difference which. I'm going to use, I don't know, BC. Okay, so I'm just picking any 2 you want out of this triangle. It does not make a difference which. So B is BC, so C minus B is 1, and negative 1, and negative 1. And now I'm going to cross A and B. Same old thing. So A is this numbers, B is those numbers. We'll crisscross them. So 0 minus, be careful with signs here this time, 1. Negative 1 minus, that's a positive 1. Positive 1 minus 0. I'm thinking we're going to get negative 1, negative 2, and positive 1. That's my vector. I want its magnitude. So I'm going to take A cross B. Take its magnitude. So we're going to square our components. 1 squared, 2 squared, 1 squared. I think that's 6. So help with the square root of 6. And I'm going to say the word area, because my area isn't root 6, it's actually root 6. It's a triangle this time, right? Over 2. And I'm going to throw the word units squared on the end, because I don't know what the units are. And there's a real quick example of how we can actually use this cross product idea. Okay, that's the end of the lesson. We got some new technique. It's really just working cross product. Yes, you may be asked for some questions that have some other things in between, like dotting or adding or subtracting or things like that. We should be confident with all our techniques. A couple questions for you to try. Okay. This is just what areas of things, how to use them. This is practicing your cross products. If you're stuck, come see me, send me questions, I'll help you out.